Okay, in this video we're going to talk about mixtures, but before we get into the concept of mixtures, first let's understand what a substance is. A substance is something that contains only one type of matter. So that's a substance. I'm going to write an example up here. Let's say water. Okay, the formula for water is H2O. Water contains only one type of matter. Another example is sucrose. Sucrose is a type of sugar. All the molecules in sucrose are the same. Okay, so these are examples of substances. They only have one type of matter. They're not mixed. It's just one thing. A mixture is a combination of substances. So if I were to get the sucrose and place it inside a cup of water, that would be an example of a mixture. Okay, so let's take a look at this picture that I drew down here. So here we have water, and like I said before, water is a substance because it only has one type of matter. But then if I were to add salt inside of this glass of water, then we would have a mixture of water and salt. Another example of a mixture is soda pop. So you open your fridge and you grab a soda and you want to drink it. That is an example of a mixture because soda is made up of sugar, it's made up of carbonated water, and it also has coloring. Okay, let's continue. Now there's two kinds of mixtures. One type is called a homogeneous mixture and the other one is the heterogeneous mixture. A homogeneous mixture is a type of mixture with a uniform composition. What that means is that when you mix those substances together, they're going to mix in a way that they become one. So let me go up here and show you what I mean by that. Okay, so the example of water and salt, if you place salt inside of the water and you stir it with a spoon, the salt and the water become one, and that's what I mean when I say in uniform. So this is definitely an example of a homogeneous mixture. Okay, so salt water is an example of a homogeneous mixture. Water with sugar is also an example of a homogeneous mixture. And soda is also a homogeneous mixture because the sugar that's going in the soda and the carbonated water and color, all of this that's going inside is going to combine to become one. Alright, the next one is the heterogeneous mixture. This is something that is not in a uniform composition. So an example of a heterogeneous mixture is actually, I have some pictures down here, is actually a salad is an example of a heterogeneous mixture because when you look at a salad, the tomatoes, which are these red things that I drew here, and the lettuce, if you mix them, it doesn't matter how much you mix them, the tomato and the salad are not going to combine in any form of uniform, and you can actually separate the tomato and the lettuce. Okay, so a salad is an example of a heterogeneous mixture. Another example is blood. Although it's difficult to see, if you actually look at it under a microscope, blood has, oops, let me erase that. Blood has red blood cells, it has white blood cells, it has platelets, and blood also has plasma. Okay, so if you look at blood under a microscope, you can actually see the red blood cells, you can see the white blood cells, and all of this kind of stuff. The red blood cells are not combined with the white blood cells. These are two different things and they are not in uniform. They're actually separate inside of the mixture, just like the salad is with the tomatoes. Okay, so let's go down here. The last thing that we're going to do is separating mixtures. So let's take a look at this salad bowl that I drew. One way to separate the lettuce and the tomato is by grabbing a fork and taking out the tomato. Okay, so I can grab a fork and just take out the tomato from this salad bowl, or I can take out the lettuce if I wanted to. So that's one way of separating it. It's a physical way of doing it. Okay, here we have another way of separating a mixture. This is a bowl of rice. Like if when you're cooking rice, you know how you have to wash the rice first, and then you have to drain the water because that water is actually dirty. When you drain the water, the rice is actually staying in the bowl and the water is coming out because you're carefully pouring the water out. That form of separation is called decanting. Okay. Okay. In your house, if you have air conditioner, the air conditioner has a filter, and that filter collects dust, pollen, and other germs that can make you sick. So the air filter collects solutes or solids, and this is a type of a way to separate a mixture of things. Okay, so this is called filtration. Okay, and the last example that I have here, it looks kind of funny, but this apparatus is undergoing a process called distillation. And let me first explain to you the steps beginning on this side over here. This is tap water, and tap water is simply water with certain elements like iron and other elements in there. So let's say you don't like tap water, or you need to remove those particles from the water. The first thing you do is set up this distillation apparatus, and what you want to do is apply heat so that the water can evaporate. So what's going to happen is the water is going to evaporate, and the particles or the elements like iron are going to stay here in the bottom. They're going to stay behind, but the water is actually going to evaporate, and the water is going to travel through this tube, okay, as a gas. So you're going from liquid to a gas, and it's going to travel all the way down the tube, and when it gets here, the gas is actually going to turn back into a liquid, and you're going to have pure water, distilled water. And how does that work? Well, this distillation apparatus has two entries. We have one entry over here, and you have one entry over here. And what you do is you connect a hose through this entry right here to the sink. So water actually goes here, and there's actually a separation in here, so the water doesn't actually touch the gas. The only reason the water is going in here is to cool down this water. So the water goes in, and then the water needs to come out through here with another hose that you use to take out the water. And then that water is going to cool this water vapor and condense it, and you're going to have liquid water here. So that concludes this video.